previous class we have discussed the saturated solution and the effect of heating and cooling on saturated solution. We have seen that when a saturated solution is cooled down, then in that case crystallization occurs. Why this is so? On cooling the saturated solution, the molecules of the solvent come closer, and when they come closer, then the interparticle space between the solvent molecule decreases. When this interparticle space between the solvent molecule decreases, then the dissolved solute will separate out, will crystallize out, and the process is termed as crystallization. To the next, we have discussed the effect of temperature. It means on increasing temperature, the solvent molecules move far apart. When they will move far apart, then their interparticle space increases. And when interparticle space increases, then more and more solute can be dissolved, and that type of solution is termed as unsaturated solution. It means on increasing temperature, a saturated solution becomes unsaturated. That means on increasing temperature, a saturated solution becomes unsaturated. The first one. The next is that on decreasing temperature of a saturated solution, then crystallization occurs. But the solution remains saturated. To the next, we will know how to prepare a saturated solution. How to prepare a saturated solution. Let us have a beaker. Fill it with water, because we want to prepare an aqueous solution of sodium chloride, a saturated solution of aqueous sodium chloride. Then in order to prepare it, what we take? We take a beaker and fill it with water. On filling it with water, now we maintain the temperature constant. Constant temperature. Let's say 30 degrees centigrade. Now what we do? We start dissolving sodium chloride into it. When we start dissolving sodium chloride into it, what we do? We add sodium chloride and then stir it. This process is continued on and on until the added sodium chloride precipitate in the solution. That means what we can say, that this process is continued until the added sodium chloride is not going to dissolve in the solution. Then in that case, the solution becomes saturated. That means solution becomes saturated. To the next, we will filter this saturated solution, saturated aqueous solution of sodium chloride. What we got? The filtrate moves downward. What we have seen? when we filter it by the use of conical flask, by the use of filter paper here, then this one is filtrate and residue is here, that is undissolved sodium chloride. Undissolved NaCl, that is here on the filter paper. This contains the filtrate and this filtrate is the saturated solution. Saturated solution, aqueous solution, saturated aqueous. Aqueous means we have prepared this solution in water, therefore it is termed as aqueous. Saturated aqueous solution of sodium chloride. This is how we prepare a saturated solution of sodium chloride. What we do? Let us divide into various steps. The first one, we take a beaker, and fill it with some water. The next, by maintaining constant temperature. Why the temperature is constant? Because we know temperature has effect on the solubility. Therefore, what we do? By maintaining constant temperature, let's say 30 degrees centigrade, we start dissolving NaCl into water. On continued dissolution, a stage is reached that added sodium chloride is not going to dissolve, but settle at the bottom of container. We will filter the solution by the use of filter paper. To separate the undissolved salt from the solution. And we have the filtrate form of saturated solution. This is how we are able to prepare a saturated solution. It means this filtrate, which is devoid of residue, is a saturated solution of sodium chloride in water. Let us see, when we cool this saturated solution, again on cooling, crystallization occurs. And when we heat this saturated solution, then this solution becomes unsaturated. You know the reason? That on heating, the water molecules move apart, increases the interparticle distance, create vacancies in which more solute can be dissolved, then it will become unsaturated on increasing temperature. But on decreasing temperature, crystallization occurs. Though crystallization occurs, but the solution remains saturated. This is all about how we can prepare a saturated solution. Next to that, we will discuss the solubility. We know when we have a beaker, fill it with some water at a constant temperature. When we start dissolving, let us say sodium chloride into it, on continued dissolution, a stage is reached that the added sodium chloride is not going to dissolve. It means that much amount of sodium chloride which is dissolved in that much solvent at a constant temperature is known as its solubility. Solubility, it means the maximum amount of solute that can be dissolved in a specific solvent, in 100 ml of a specific solvent at constant temperature, that is known as solubility. Let us know it. The maximum amount of solute that can be dissolved in 100 gram of a specific 100 gram of a specific solvent at specific temperature. It means the maximum amount of solute that can be dissolved in 100 gram of a specific solvent at a specific temperature is known as its solubility in that solvent. What it means? It means we have seen here that the maximum amount of the solute that can be dissolved in 100 gram of a specific solvent. It means the quantity of the solvent is 100 gram. It means it is written here specific because when we change the solvent, then the solubility changes. At a specific temperature, it means when we change the temperature, the solubility changes. What it means? It means solubility depends upon certain factors. What are these factors? Let us know. The solubility, it depends upon following factors. The first one, nature of solute. The next one, nature of solvent. The next one, temperature. And the next one, pressure. But in this class, we have to discuss the effect of temperature and pressure on the solubility of the gases. But I will discuss the nature of solute and the solvent. It means when we change the solute, the solubility changes. When we change the solvent, the solubility changes. When we change the temperature, the solubility changes. When we change the pressure, solubility changes. In this context, in case of nature of solute and the solvent, we know like dissolve like. Like it means, you will study in the next classes, that covalent compound dissolve in covalent solvent, such as naphthalene dissolve in benzene, naphthalene dissolve in carbon tetrachloride. It means the covalent solute dissolve in covalent solvent. To the next, the ionic solute dissolve in ionic solvent. It means if we have a sodium chloride, it is ionic, it will easily dissolve in water because it is polar in nature. It means like dissolve like. In this context, what we know, like dissolve like. It means ionic solute dissolving in ionic solvent. The next one, the covalent solute dissolve in covalent solvent. It means the solubility changes on changing the solute and solvent. What we see here? We see that on changing the solute, on changing the solvent, the solubility changes. The next one, we will discuss the dependency of temperature. How the temperature? It means in case of solubility of solid in liquid, let us say the example of dissolution of or the solubility of sodium chloride in water. It means in case of the solubility of solid in liquid, on increasing temperature, the solubility increases, and on decreasing temperature, the solubility decreases. I have explained you many times before why this is so. The first one, on increasing, in case of solubility of solid in liquid, the solubility increases on increasing temperature. In case of solubility of solid in liquid, the solubility increases on increasing temperature and solubility decreases on decreasing temperature. The next we have the pressure has not the effect of increasing or decreasing solubility. It means the pressure has not the effect on the solubility of solid in liquid. Why this is so? Because the solids and liquids are incompressible. Therefore, pressure has no effect. It means the next one, the pressure has no effect. No effect on solubility of solid in liquid. This is so because solid and liquid are incompressible. Next to that, in case of dissolution of gases in liquid, in case of solubility of gas in a liquid, when we increase the temperature, on increasing temperature, the solubility of a gas in a liquid decreases. And on decreasing temperature, the solubility of gas in a liquid increases. Next to that, on increasing temperature, the solubility of gas in a liquid decreases, and